Welcome to Start Local, where we talk with business owners, leaders of nonprofits, and other members of our community focused on doing business in and around Chester County, Pennsylvania. Each episode will provide insight into the local business scene and tell you about opportunities to connect with and support businesses and nonprofits in your local area.
The Southern Chester County Chamber of Commerce promotes trade, commerce, industry, and sustainable economic development while supporting a diverse and growing marketplace. The Chamber is proud to partner with the Start Local podcast to raise the profile of businesses and nonprofits throughout Chester County. Learn more about the Chamber at sccc.com. That's sccc.com.
Hey, I'm Liam Dempsey. Welcome to the Start Local podcast. I'm here yet again, lucky as always to be here with Eric Goodmanson. Eric, how are you today?
Well, I don't know if you'd say lucky, but I am doing well. Nice to see you, Liam.
Yeah, no, I think I'm lucky. I like hanging out with you. But today, folks, we have a really exciting guest for us to talk to. We're going to welcome John Jackson. He's a senior researcher at the Stroud Water Research Center. And the Stroud Water Research Center, or the Stroud Center, it's tucked away in the southwest corner of Chester County, Pennsylvania. Yet from that bucolic little corner of our region comes some of the most advanced and in-depth research into freshwater systems. John, welcome.
Thank you. It's a pleasure to be with you guys. Thank you for the invitation.
John, thank you for taking time from your busy schedule to be with us today. We're looking forward to the conversation.
I think it'll be fun.
John, I did a lot of research before the conversation today, and I really enjoyed it. But I think it would be helpful for the audience to get a bit of context for the things we're going to talk about today. The Stroud Water Research Center was founded in 1967. As I shared, it's down in southwest Chester County in Avondale. And it's a world-leading institution, and you're focused on producing innovative solutions for preserving and restoring fresh water. I got that from your website. Unpack that a little bit. Give us a brief overview of what sort of research and activities you and your colleagues are spearheading every day.
So we have probably easiest way to characterize it is two types of projects: short-term projects, things that are just getting started, smaller, very focused questions. And then we have longer-term projects that are addressing more complicated problems or more complicated questions. Remember, every project, when you're a scientist, every project starts with a question. That's where we start, is what's going on here, or what does this mean? Many of our projects start out smaller, just to get your foot in the door, and then they evolve into these longer-term things that may, in many cases, be decadal. And that's because the environment that we live in is really complicated. And so understanding it, and that's what science is, it's just the study of the world we live in, and especially the natural world. And when you're an environmental scientist, that means the physical world, the chemical world, and the biological world. So it's complicated, and that's without people. So then when you add people into the landscape, the dynamics are, let's put it this way, there's never a boring day. You're always finding something you didn't know. So that's how our research gets structured. But to think about your question, what are we doing on a day-to-day basis? Research. We have 7 or 8 Ph.D.s on staff, on the research staff. They have a lot of different expertises, different experiences, different interests. And so our projects are across the board. But one thing is about understanding natural streams, and the other set are streams that have human footprints on them more, or aspects of our environment that have that human footprint more evident in them. So it could be we're doing studies about degradation and restoration. It could be studies about toxins. It could be studies about alternative farming practices, sediment in the stream, sediment up in the fields. And then you start seeing the connections. Studies of pesticides, new pesticides, or studies of PFAS, Both of those are human things tied to toxins, tied to agricultural things. So as diverse as things are, they really are connected to either natural systems or people systems.
That is a world of possibilities that lots of scientists could go into when it comes to fresh water. So let me ask about you specifically. What is your academic area of interest and focus? Or to ask it another way, what do you study and why?
So in short, I'm the bug guy at the lab.
You don't look like a bug guy, but that's okay.
I embrace it. So I have a Ph.D. in aquatic entomology and stream ecology. And so what I am is a biologist who studies ecology of streams, and I use aquatic insects to ask and answer my questions. So that's how I am as a bug guy. The characters of my scientific play are generally aquatic insects.
And is it fair to say you can measure the health of a stream by the kinds of insects and the quantities of insects that are in that environment?
Absolutely. It's one of our most useful tools. It's a tool that's used worldwide. It's been used for over 100 years. It works in streams. It works in lakes. These guys are out there 24/7 sampling the water, telling us whether they like it or not. And because there's a lot of them, it's a lot of different opinions about how they like it or not. And that gives me a sensitive indicator of stream health.
John, as we find ourselves in midwinter and just coping with overnight snow here, let's turn to a topic that you and your Stroud Center colleagues have been talking a lot about. I've been seeing it in your newsletters, on your website, some local press coverage and the like. And it's about winter road salt. How is road salt a freshwater systems issue? How does that come together? What does that mean?
This is something that research has been addressing now for almost 20 years, a little bit over 20 years. But the public knows next to nothing about it. It's really below the radar. And the issue is we apply millions of tons of road salt in the United States every year. At present time, we probably apply about twice as much as we did in 1990. Everybody knows it. You see the trucks go by your house. But you don't think it's a problem because it rains or the snow melts and the salt dissolves and goes away. But what they don't realize is it doesn't really go away because a portion of that runoff goes into the ground, first goes into the stream or into the ground, and then it starts coming out of the ground. So over the decades, we've been slowly replacing fresh water in our groundwater with salt water in our groundwater. And therein lies the problem. So we have two problems with road salt. One is the short-term storm event. So it snows or it's an ice storm. We apply lots of rock salt and then it melts and the road salt dissolves and it goes into the stream. And you measure a spike, a big spike. The big ones we've measured in 3 or 4 locations in the area, including Chester County, a spike that equaled seawater. So we had the salt of seawater in our freshwater stream for a few hours, maybe multiple times in a winter. Depends on the storm, depends on the location.
Wow.
We've even, outside of Philly, north of Philly, measured twice seawater in a spike.
Wow.
But we have another problem that we're paying more attention to, and that is we go out and sample this stream in September, October, November, months after the winter. And the stream's still salty because portion of that salty water went into the ground. And over the decades, it's just made that groundwater saltier. And that water, if it hasn't rained in a few days, all the water in your stream is groundwater. And now what it is salty groundwater. So that's the environmental problem.
So, what can our local township managers, roadmasters, facilities managers, and others with responsibilities for our roads, parking lots, and sidewalks, and even homeowners for that matter, what can we all do to reduce salt usage? Because we still need to get around in the wintertime.
Well, my approach when talking to the decision makers is actually not to start with the environmental aspect of it. It's that which I know the best, but it's also that which is maybe tangential to the issues that the deciders have to deal with. So I focus on drinking water quality and infrastructure. And most people don't really think about it, but our drinking water is being impacted by road salt, but so is our infrastructure. They've done some calculations. $100 worth of road salt causes about $3,000 worth of infrastructure. That's roads and bridges. That's rust on your car. That's damage that eventually we're going to have to pay for, whether it's fixing your brakes more often or replacing a bridge more often. So that's how I open the conversation. And it's going to be a long-term conversation because right now they're doing what we asked them to do. We asked them to make the roads clear. But if we don't change our application rates, the problem's only going to get worse. So we start the conversation with that as the platform and then say, well, what can we do? What can we do that's different? And there's two choices. They go hand in hand. One is mechanical removal, which could be plows, better plows, live edge plows, sweepers, brooms, things like that, mechanical removal. Maryland uses a lot of brining, even during the storm, as a de-icing technique, but also making sure that you don't use any more than's recommended. In other words, calibrate your application. And the thing is, and nobody's surprised that we have a problem. Our challenge is, at this point, we're addicted to the conditions that excess salt use creates. In other words, clear roads, literally in the middle of a blizzard, if you put down enough rock salt. So that aspect of the public expectations and the public needs are also going to be part of the conversation. But our problem is because people asked for it. Our problem is there because we wanted these conditions for safety purposes, for economic purposes. It's just the infrastructure and the drinking water and the environmental issues never came into the conversation until more recently.
John, you talked about water quality as a road salt related issue, and before today's conversation, you and I were chatting about water quality and water research, and you were educating me on the role that road salt played in the enormous water issues that Flint, Michigan has been suffering for a long time now. Can you walk us through how road salt affected the lead pipes in Flint?
Yeah, now it's important. I have to acknowledge that this wasn't my work. So the ins and outs and the very specifics, but how I understand it is the city of Flint, Michigan switched from a water source, probably the Great Lakes, that was very dilute, had very little salt in it, to the Flint River. And in doing so, the Flint River had a higher salt load. In making that switch, they brought more salt into, so this case, sodium chloride. Most people don't realize that the rock salt, the road salt, is just the same as table salt. It's sodium chloride. That brought the sodium chloride into the drinking water systems. And the first thing that excess salt did was strip off the scaling. And a good drinking water system has developed some scaling inside, so it protects the water from the pipes whether they're copper or lead or whatever. Well, once the scaling came off, then it gave the salt access to the lead in the old lead pipes, and it mobilized that lead. So when we hear about the Flint, Michigan problem, we hear about lead pipes and lead in the drinking water. But what most people don't hear about is what changed was the water source, and they started using a water source that had a higher road salt contamination. And that is what led to or contributed to the mobilization of the lead. The other thing is my understanding is some of that could have been avoided if they used an anti-corrosive. But the devil's in the details there. What really mattered was that the water, the contaminated road salt, stream water or river water contaminated with road salt contributed to the mobilization of the lead and the lead problem in the drinking water.
And just to clarify, by mobilization, you just mean that the lead left the pipes and went into the water, dissolved into the water. Got it. Thank you.
It went into what we'd say into solution.
Thank you.
So
let's bring it back locally, if I could, to the different Stroud Center research projects that are going on. Is there a flagship project that's kind of happening right now, or maybe like what are the top couple research projects that are going on? And I'm also very interested to know how you pick what research you're going to do, because I imagine there's no shortage of questions that you and the other scientists there at Stroud want to ask.
Well, it depends on your funder. That's the first thing. So some funders, the sky's the limit, and other funders are very focused and asking you to propose a project to address this issue. Could be a general issue, could be a very focused issue. So in some cases, we get to follow our best ideas. In other cases, we follow our best ideas, but in a more focused way. And again, you're not going to get funded by putting out ideas that others have pitched. So you really have to push the envelope, say, what do we need to know? What's important? A project that I've been working on, or the lab has really been working on, all of us, I've been writing it up, is almost 30 years old. And it was one of our early studies. It started in 1995, just looking at the recovery of a stream if we replanted the streamside forest. So all of these streams around here, this was Penn's Woods. That's what Pennsylvania translates into, is Penn's Woods. It's not Penn's Meadow. It's not Penn's Wetland. It was Penn's Woods. And that's because, this area, if you cut down the trees came back. There were some meadows and there were some wetlands, but the defining character was woods. Well, at a certain point, we cut down enough woods and we had such limited regrowth that we ended up with, it would be fair to say, anywhere from only 0 to 25% of our streams with forests. So for the last 30 plus years, we've been working on the science of what does that mean, and then when we replant it, how quickly do we get the characteristics of that natural forested stream? We've done a lot of work in that area. We've of that role of developing better predictive understandings, because that's really what the people want us to fix problems, but they also want to know, well, how long is it going to take? And that's very hard to do when you're not doing something that's very invasive. You're letting nature heal itself. We give it a little assist at the start. We put in a tree that's 12 to 24 inches tall and is thinner than your finger, and then we let it go. other research that we've looked at are tied to sediments, whether they're up in the fields or down in the floodplain. In the floodplain, they call them legacy sediments. In the fields, we call it field erosion. You've all seen it, big rain event, a lot of mud moving around. What does that mean? These are all projects. These are common questions. The answers sometimes vary with your landscape. So another thing that we might do is either have to repeat it more than once, and it's very hard to repeat a 30-year experiment.
I bet.
But at some point, somebody's going to need to make sure that what you observed is repeatable. The other thing is you may intentionally try to repeat it, but pushing it into a different environment to see how that changes. It's the difference between going from the mountains to the Piedmont to the coastal plain. They're different landscapes, different geographies, and it's safe to assume, at least initially, that nature's behaving differently in those different landscapes.
And as you're talking, I suspect I've inadvertently participated in some of that research because I've done some of the Stroud Center tree planting days where they have like maybe a team building exercise, or we get out some nonprofit organization to come out and plant a bunch of trees. And what I've noticed is that some people are planting different types of trees. There might be different types of protectors around the trees. And I suspect that your scientists are probably measuring, okay, which types of tree protections, which types of trees themselves do a better job to accomplish the mission. Is that part of those volunteer days?
Some of them are. It's specifically designed to ask and answer questions. It was the Stroud Center, Bern Sweeney, the last director. He has retired now, but he was the first person in North America to bring tree tubes to this area. And the reason why is their early tree plantings failed. And that was because of voles and deer browse. And so nothing would grow back if we didn't give it the assist of the tree tube. He also discovered that the tree tube helped him through a summer drought. And because of the condensation, it self-watered. So it was a win-win to put the tree tubes on. But we needed to do the science to show people that was quantifiable. Then there were other techniques about how was the proper care, what was the most efficient. Maybe the last thing we've done, and I'm not completely on top of some of that work because that's a partnership between the restoration team and the science team, and I'm not always involved. We did some work, some experiments to use stones around the tree tubes to seal the bottom, to keep the voles out, to keep the weeds away from the tree. And that allowed us to not use herbicides. And that also allowed us to do fewer visits in maintenance. So cutting the cost, cutting the chemical use, and some of our landowners are sensitive to the chemical use. And that might have been twice a year we'd have to go out and spray the weeds around the trees, because if you don't, they'll strangle the tree. So it's all been a process of improving the success and in the end reducing the cost to either the landowner or to the team that's actually doing the replanting.
John, you shared with us that there are currently 7 Ph.D. holders, researchers working at the Stroud Center. And from what you've just shared in the course of this conversation, it's clear that there's a lot of different sides of research going on, right? Not just looking at the water or the soil, but the trees, and looking at the rocks around planting the trees. So there's a lot of stuff going on there. How do you and your colleagues go about recruiting new researchers, new scientists? And I guess I'm kind of wondering, how do you identify a focal area that you need? We need somebody that knows about this. And then I guess on the other half of that is, how do you go about retaining people? I expect it's a competitive market. And if you're doing really cool research, you'd have a lot of people that want to work there, but maybe they want to go on and become an academic and stay indoors where it's warmer or air conditioned more consistently. Talk to us about how you recruit and how you retain, please.
So we recruit at at the scientist level, at the Ph.D. level, much the same way as the university does. Just like you said, what's our need? But the university quite often doesn't look at it the way we do, in that our need is within the research team. So I'm the third generation aquatic entomologist, and presumably when I retire, there will be another aquatic entomologist, because it's a key spoke in that wheel that is our research team. But we do step back and say, well, we need this or we need that, and then we do a search just like a university would, reaching out through various communication pathways that PhDs look for. And we do the evaluation both on their expertise, but also their ability to fit into the team. In other words, their expertise as it meshes. So is it something new that we need, or is it some combination of new that we need, but also essential that we can't live without? That kind of evaluation. In terms of retaining, that's a hard question for me. I felt very lucky being at the Stroud Center for my career, and I've never really thought about leaving. And it's not like I grew up here. I grew up in Denver. I went to school all over the country. But this is a very unique place, so I'm able to do great science with a great team of people who are my partners in this endeavor, both at the PhD level and also at the technical level. So it's been a terrific opportunity for me. But I recognize that other people's lives change and things, they may need to move on. And when that happens, we're sad to see them go, and we then start over. But we've had great success at retention. And that's, I think, because the Stroud Center is a unique opportunity.
Well, it seems like people are very passionate about it, not just the people who work there, but also the people who volunteer there, and also the people who give money to Stroud Center. So how does Stroud Center fund its work? Would you walk us through the business model a little bit? You earlier alluded to the fact that the funders essentially fund the research and help to dictate their research to some extent. So I'm just curious how that all fits together.
Well, I would guess about 75% of our operations are grants and contracts. It's outside money. And that's almost all competitive. In other words, you're tossing out your best ideas, and the funder is deciding to choose team A or team B. About 25%, though, is endowment. And we are so lucky to have the endowment. The endowment is vital, in part because it helps us take the time to develop new ideas, to develop a new skill set, to develop a new data set that's foundational for something new that we need to work on. The other thing, and it's tied to that, is it helps us financially bridge between grants and contracts. You're never batting 1,000 in this business. You're not batting 500. And so you have to have a little safety net, and that safety net is the endowment. And we didn't always have it, and now we do. And it's a game changer in creating the stability within the research teams.
John, the Stroud Center has a deep connection with the arts. I was reading about that on your website, and in my visits to the Stroud Center, there's lots of sculpture and painting and the like. Can you give us a brief overview of that connection and touch on its value to the work that's being done at the center? It's not necessarily an intuitive connection between the arts and science, or water research and the arts. So help us understand that.
It's really, from my perspective, I wasn't here, but it started from our very beginning. And it had to do with our benefactor, W.B. Dixon Stroud. Dickie Stroud had a real strong interest in the arts, He was very active in the arts in Philadelphia. And he cultivated that creative connection, that creative environment at Stroud, recognizing that visual stimulation, representations of nature, that he didn't want the Stroud Center to just be another cinder block research lab. So structurally, we don't look like that. We look like we belong in the countryside of Chester County. And inside, he had art in the hallways or in the offices. We were also lucky enough after we created that environment, and I think what he recognized is the environment that is creative for artists is also creative for scientists, and that the creative process for artists and scientists, there's a fair bit of overlap, because in both cases, they're trying to understand, they're trying to deconstruct and then reconstruct the nature, the environment around them. Very different approaches, but in many cases, the same subject. That same approach, we've had the great fortune of working with Jamie Wyeth, working with the artists that he brings in down on his farm, excuse me, and helping them see how scientists would look at nature at the same time that they are looking at nature as an artist. And our educators have worked with them, our scientists have worked with them, and I think that's been a terrific opportunity. And Jamie Wyeth recognized it and built that connection. So I think it's been there since we started.
I'm so glad to hear you talk about the creative environment for the arts is similar to the creative environment for the scientists. Because we hear a lot about, oh, I'm a creative, I'm not a scientist, or I'm a scientist, I'm a techie, I'm not creative. And I am not a scientist. I do struggle with things like the advanced physics, the advanced math. My brain does not get into that easily. But I would have thought coming up with creative ways to think about problems, creative ways to try to get at the truth of a problem, of a situation, and to remedy that, that's thinking outside the box, and that's creative. And you can be I would have thought science, especially research, is well beyond knowing the physics formulas and the chemical compositions of things. So thank you for touching on that. I really appreciate that.
I think it's been huge. I really do. It's just a lot of overlap.
We've talked about science, we've talked about the arts, and now I want to talk about education, because you're also known at Stroud Center for supporting learning and education for young people. I know a lot of folks from local high schools, colleges come to Stroud Center from all across the region and maybe beyond to learn about freshwater. So talk to us a little bit about your educational programs.
So the Stroud Center didn't start with educational programs. We started as 100% research. Then we added education, and later than that, we added our restoration team. But we've always done education. Science without a communication aspect isn't science, it's hobby. You're playing around in your garage doing what you want to do, but you're not sharing it with anybody. So there's always been an educational, a communication component to our science. But we knocked the doors down of the Stroud Center in the early 1990s and started opening up by opening our education program. Now they like to say that they work from K to gray. We certainly work most extensively with the elementary and middle school kids. We probably have 10,000 or so student and teacher contacts per year, some at the Stroud Center, some of them at the school itself. Part of that outreach to teachers is because if you teach the teacher, then that teacher reaches dozens, if not hundreds, of students every year. So you magnify your impact for every one of the teachers that you have the good fortune to work with. But at the same time, we still engage by way of our research and restoration teams, the professionals, the general public, teaching our science, teaching our perspective, trying to help them look at their world a little differently. The restoration team has contact with hundreds of professionals every year. We have presentations at the lab every year. And we also, even the research team, we still have our spring course in freshwater ecology at the University of Pennsylvania. We do guest lectures at different other universities around here. So trying to play a role in that next generation of not scientists alone, but rather better citizens that are more attuned to how science works and how the environment around them works. And therefore, they can play a better role, because the world that we see is the world that we ask for. And the only question is what are we asking for?
The Stroud Center has its own Test Creek, its own river system right there within the labs. And when I visited your facility, in one of the labs there, I think it was in the basement, you'll correct me if I'm wrong, there was this very large room, and there were more red Coleman coolers than I've seen anywhere in my life, more than any tailgating party I've ever been to when I went to a Big Ten university. But seriously, though, talk about that test river environment. How does it work, and what sort of research do you do with it?
So the Stroud Center is a field research lab. So we're in the field. We're right next to the east branch of White Clay Creek, which is the drinking water for Newark, Delaware. That's our landscape. But in doing our science, whether it's on this branch or the next branch, or we hop over to Red Clay or over to the Brandywine, at some point we need to tease things apart. And that lab that you walked into is a powerful scientific tool. We can recreate nature in the building. And in recreating nature, we can manipulate and control things. So we can control temperature, we can control light, we can control water flow, we can control the food, we can work with fish, we can work with bugs in there, and we can figure out what is important to them by changing things the way science does. You know, the way we do a controlled experiment is make all things equal, but change one thing. You warm it up or you cool it down. And in that lab, in one rack, I can create summer conditions in Pennsylvania, and in the rack next door, I can create winter conditions for Pennsylvania. And next to that, I could do Maine, and after that, South Carolina. Well, these species that we work with in southern Chester County, they don't just occur in southern Chester County. They occur throughout eastern North America. How do they do that? Well, that's what that lab helps us do, is understand how they can be in Alabama, in Pennsylvania, and Quebec at the same time, same species. Those are clearly different worlds. And that's what science needs to do. So we have the greenhouse, we have that lab. We create all sorts of experimental tools that allow us to take nature apart and then put it back together, and in the process learn what's going on.
Yeah, that's so interesting, that kind of level of control and having variance and the like. I wasn't joking, John, when I said it was more coolers than I have ever seen in one place in my life. Just for my own curiosity, humor me. How many coolers are part of that setup? When we didn't have the coolers, we had over 500. The coolers are a little thicker, and the coolers are important because for temperature, I can drive the temperature colder and warmer, and I don't have to lose as much energy. It's more efficient. I have better control, just like you do with your house. You insulate your house to have better control in the summer and in the winter. I would guess there's over 300. It's when we ordered them, the guys at Coleman wanted to know what we were up to. I bet they did. Should we come to that party? No, we're scientists.
And
and when they arrived, it was an eye opener. You've never seen so many boxes of Coleman coolers.
And you do eat your own dog food in the sense that, and I don't mean that literally, but what I do mean by that is your sewer system. When you run water at Stroud, it doesn't just go down the drain per se. It has a whole special treatment center behind it. So could you explain that part of it a little bit? That's an interesting part of the tour of the underbelly of Stroud.
That's an interesting observation that you've made, because I usually have to point people out because it's really behind the scenes. It doesn't jump out at you, both for stormwater and wastewater, that what we've tried to do at the Stroud Center is create and demonstrate what's possible. So if you were to look at our wastewater system, we don't send a pipe to the stream. What we do is we take all of our gray water, all of our solid waste, and we, to the best of our ability, process them and make it cleaner than it was when it came into the water came into the lab. So we have 2 bathrooms that are all composting toilets that are very efficient and in general require no maintenance other than letting the worms do their work in there. Then the liquids go through a series of treatments, wetland treatments, as well as through a sort of a sand filter before it's dripped into an old ag field. So drip irrigation, no discharge. But the water quality, we're removing enough of the nitrogen and phosphorus in that process that the water is cleaner than it was when we pulled it out of the well. The stormwater is another great example. When we upgraded both of these, we started with composting toilets back in the mid-90s, about 95. And we reduced our water use by half just by doing that. And now with the 2 systems, it's even more efficient. The waste or the stormwater, what we did, and we had a great consultant, Michelle Adams, who designed this system and worked with us and really merged our desire to have the smallest footprint possible. And if you were to walk around, you would see a bunch of rain gardens that are all connected. And so all of the water off of all but the oldest portion of the campus goes through a series of rain gardens. And there's no pipe to the stream. The only way water gets to the stream is if it goes through this whole network, and there's still excess. It goes through a level lip spreader across the floodplain. And what we're trying to demonstrate here is how much you can infiltrate. You don't have to send it to your neighbor. You don't have to send it downstream when it rains. You just have to, by design, ask people, how do we keep the water where it falls? And whether it's for flooding or whether it's for recharge of your groundwater, in both cases, the environment is better. Your environment, your living environment is better if we can keep more of the rainwater where it falls.
That's impressive. That's really impressive.
Yeah, thank you for sharing all those details about Stroud Center, because I think it's amazing research that's being done, right here in Avondale. So very, very impressive. Let's talk about a local business or a nonprofit that folks should know more about. Any organizations come to your mind?
We have so many partners, some closer to us. And I'll stay focused on the nonprofits. Brandywine Conservancy, Brandywine Red Clay Alliance, Natural Lands, the Nature Conservancy, Willistown Conservation Trust. These are all very close to the Stroud Center, great partners. They're great environmental organizations. But if I was to think, I'd probably have over 100. If we go a little further away, again, some of these are very place-based, like Berks Nature or the Green Valleys Watershed Association up on French Creek, Perkiomen Conservancy. Some of them are all volunteers, like Valley Forge Trout Unlimited. They're a terrific environmental advocate for Valley Creek, but also for other waterways around here. So I can't say that there's any one that we work with exclusively. And then we have the universities. We have close ties to Westchester University, Millersville, University of Pennsylvania, University of Delaware. And if you were to think about our education program, they're reaching out to public and private schools. So all of those private schools are probably nonprofits, and that's in PA and in Delaware.
That's a lot of partners.
We have a lot of partners, partially because of the subject, partially by design. What we're doing is complicated, and it requires partners, whether it's on the ground familiarity with a landowner or a skill set that we just don't have.
John, you and your colleagues for a long time now have been doing a lot for the local community, doing the research, sharing your findings, helping governments and other entities make decisions, drive things forward in ways that best suit the decision makers and the public that they're serving. But how can the local community support the Stroud Water Research Center?
But I think that one of the easiest ones is just subscribing to our newsletter, so you see the updates, you see what's going on, and attending some events, following us on social media, things like that. They can come visit the Stroud Center. Those evening events are an opportunity to visit, learn more about what's going on. Maybe even in the case of businesses, providing sponsorships for speakers so that the community benefits. That's true for an individual or a business. Individuals and businesses, a major fundraiser for us is the Willowdale Steeplechase at the intersection of 926 and 82. This year, it's always in May. This year, May 10th? So it's an all-day event. It's a fundraiser for the Stroud Center and for the University of Pennsylvania's vet school, the New Bolton Center. So 2 Chester County nonprofits benefiting from the steeplechase. And that's a great day of just being outside. Another thing that's good for businesses is the ETIC, the Educational Improvement Tax Credit. I don't know a lot of details about that, but if a business was interested in that, they could reach out to the Stroud Center, and we have experience facilitating that kind of connection. And there's a number of businesses in the region that help support us that way.
Is the Stroud Center currently hiring? And when you're hiring, where can folks learn about employment and career opportunities?
Our postings change all the time. On the Stroud Center website, you just look under employment and you'll see the announcement. Right now, education department is looking to hire some part-time environmental educators, especially bilingual Spanish-English environmental educators, which those of you who know Southern Chester County would see value in that. There are microbial ecologists. Jinjun Khan at the lab here is looking for a postdoc for the summer, and the restoration team is looking for some summer interns this summer. The science team right now is not advertising any, but my guess is at least a few might come in. I'm not sure what my team is going to do this year. I have to figure that out in the next few weeks.
And the retention there is amazing. You've been there for 35 years. So once you check into Stroud Center, I don't think you leave.
We are lucky to have a very dedicated team. They work nights, they work weekends, they work when it rains, they work when it's hot. It's fortunately for us, they have a passion for the work and a passion for the environment.
Well, John Jackson, Senior Research Scientist with Stroud Water Research Center. Where can listeners connect with you and learn more about your work and the work of your colleagues?
For the research end of things, go to our website, stroudcenter.org. In there, you can find, under research, you can find what's going on in research. You can also go to restoration to find out what's going on in the restoration team, and you can go to education and see what's going on in their education team. But also subscribing to that newsletter. That changes as often or maybe even more often than the website, certainly more often than my page does. And so to really see what people are up to, that comes out, the upstream newsletter comes out monthly, and that has a nice listing of advances as well as events that are coming.
John, I'm going to second the sign up for the newsletter. I received that, and it's well done. You folks have a lot going on, and there's a lot of little projects, a lot of events, a lot of toing and froing, and the newsletter quite succinctly puts it out in very digestible ways. So yeah, I recommend the newsletter. And thank you so much for joining us today, John. I've really enjoyed spending time and learning from you. Thank you.
Oh, it's been my pleasure. You guys have really made me think about what I do and why I do it, and I appreciate that. It's always good to revisit those underpinnings.
John, thank you very much for joining us, and thank you also to my co-host Liam Dempsey. I'm Eric Goodmanson. The podcast Start Local is published every 2 weeks. We invite you to subscribe to Start Local using your favorite podcast app, or ask your smart speaker to play the Start Local podcast. You can also visit the Start Local website at startlocal.co for show notes, including links mentioned on the show and summaries of past episodes. We hope you join us for the next episode. Thank you for listening.